The first thing many people do in the morning is to go online and check the conditions that might impact that day, such as traffic, weather, and the news. Similarly, in a public works environment, staff need to assess the events that impact their day. As a workforce manager, you can access real-time weather information to determine if weather could impact your crew's ability to work. To evaluate the conditions at a regional level, drill down to the service territory and review the workload for the day. From this view, you can see district boundaries and a detailed street network. Next, access the number of work orders that have been issued for the day. From this view, you can see the geographic location of the work order sites and how they are distributed across various districts. Simply hover over each work order to easily access information about the task. As you can see, the work order location is tied back to the work management system that allows you to access information about the work order and the activities that must be completed at this site. Another critical piece of information is the location of work crews. Again, I can quickly see the crew locations by turning on the crew data layer. Hover over the crew locations to see who the manager is for the crew and a cell phone number. You decide to access information about ongoing city projects. This map shows the location of the street repavement projects, noted in red, and signal improvement projects, noted by a streetlight symbol. Throughout your day, unexpected situations can occur that require you to reprioritize work activities, crews, and resources. Assume a water main breaks and you need to locate, access, and dispatch resources to repair it. The first action that needs to take place is to locate the event. Start by typing in the address location where the water main break has been reported. As you drill down to the location, more information is available to help assess the situation. High-resolution imagery helps you understand the area in which the water main ruptured, as well as see the facility information and water distribution network. You can also pull in information offered by the public, which will help you assess who the break will affect. For example, a person at the incident reports the actual location of the main break. Place it on the map and attach a photo of the current situation. This photo confirms that this water main break needs to be resolved, and very soon. To help the crew handle the situation, you quickly perform a spatial analysis on the water network to determine which valves need to be turned to isolate the break. Run the analysis. The valves needing to be turned are shown in purple. Next, assess the number of customers that will be affected by this event. The red lines denote the mains that will be isolated by closing the valves, and the yellow pins denote the customers who will lose water service. More information can be added to help assess the situation. For example, bring in parcels, buildings, and facility information from your database. Switching to 3D mode, you are better able to see relationships between the water facilities and surface features, such as streetlights. You can use this information to help the work crew locate the valve positions based on the relative position of surface features. The next step is to route a crew to the location. Because you have access to the crew positions, you can route a crew to the incident. Using the Intelligent Street Network, route the right crew from their current location to the event. As you geographically fly along the route, you see the location of other crews. This shows that the analysis was not limited on proximity, but on the crew skills and availability. You have been able to quickly locate the event, determine how to react to it, and route a crew to the location. Frequently, after an incident such as this water main break, public or city officials want to know what the chances are that another event like this might happen again. To help answer this question, you decide to run a business model that uses the characteristics of the main that failed to determine the locations of other mains with the same characteristics. In this example, the 16-inch main was installed in 1950, made of cast iron, and operates under 45 pounds of pressure. Using this information as your criteria, you locate other mains with similar characteristics. The analysis shows in red those mains that have similar characteristics to the one that failed. This information can now be used to help coordinate future projects, such as main replacements. The assessment you have just completed will minimize cost and reduce risks, both to the public and to crews.